microprocessor. You have to remember this. It is a 16-bit microprocessor. It has 20-bit address bus and 16-bit data bus. Data bus, it is responsible for reading data from and to write data to memory and ports, either 16-bit or 8-bit at a time. If the data bus is of 16-bit, then it can write or read data which is of 8-bit or 16-bit. Okay? 8-bit also, it can be read, and 16-bit also, data, it can be read by this data bus. Okay, remember this. अगर 16-bit आपके data bus है, तो 16-bit और 8-bit दोनों साइज का डेटा रीड कर सकती है and write कर सकती है. It has 20-bit address bus. Address, it is related to memory. Okay, आपका जो भी डेटा है that is stored in memory locations, and memory location पे हर एक डेटा का unique address होता है. Okay, and the address bus, it is responsible for providing access to the memory location. Okay, and 20-bit address bus, it can access up to 220 memory locations. As the data bus is of 16 bits, 80 to 8015. A will stand for address and B will stand for data. Okay, A stands for address and B stands for data. And as the first is starting from 0, the end will be 15. Okay, like in an array. Whereas A16 to A19, these are separate address buses. समझ में आ रहा है सबको? क्यों A16 से A19 separate है? Am I audible? Or the answer to this question is in the slide itself. Data bus अगर 16 bit है and address bus अगर 20 bits है, और हम इन दोनों को suppose ये आपकी data bus है और ये आपकी address bus है, इतना इन दोनों में common है तो इसको multiplex कर सकते हैं, साथ में mix कर सकते हैं. अब जो है ही नहीं common, उसको तो separate ही रखना पड़ेगा ना. समझ में आ रहा है? Yes, ma'am. Okay, my question is, here we have multiplexed address and data bus from 80 to 8015. Okay, and A16 to A19, they are separate. Is it clear now? My voice is clear?
Yes, ma'am.
Yes, ma'am.
Okay, that means I have to speak this much louder. तो यहाँ पे समझ में आया सबको कि 80 से 8015 हम मल्टीप्लेक्स किया है यहाँ पर, एंड A16 से A19 को सेपरेट क्यों रखा है? Why? Because the size of data bus is 16 bit, whereas the size of address bus is 20 bits. So first 16 bits, they are multiplexed, they are combined together into one. Okay, whereas from A16 to A19 we have separate address bus. Got it?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. Along with this, the 8086 microprocessor, it also has a 6 bytes instruction queue. Okay, it has an instruction queue and it can fetch up to 6 instruction bytes from memory, and it queues them in order to speed up the processing. Okay, such kind of queue is there. An instruction is just saved in this 6 byte instruction queue. Okay, and then this instruction queue, it stores the next instruction that will be processed, okay, in advance, so that at the time of execution of instruction, the instruction can be quickly fetched from it. Okay. Also, the 8086 microprocessor, it has 2 modes of operation, minimum mode and maximum mode. In the previous lecture, I have told you that 8086 is a 40-pin IC. Okay, it has 40 pins. The microprocessor has 40 pins, 4040, and it works in two modes, minimum and maximum. When we say that the microprocessor is working in minimum mode, some of the pins they become deactive, and the pins which are specific to the minimum mode they are active. There are two different configurations, minimum and maximum mode. कुछ पिन मिनिमम मोड में एक्टिव होते हैं और कुछ पिन मैक्सिमम मोड में एक्टिव होते हैं. Okay, we will see how many pins are there. We will see which pins are active in minimum mode and which are active in maximum mode further. Any query in this slide?
No, ma'am.
No, ma'am.
Let's see the basic architecture of 8086. The architecture of 8086 microprocessor. In its architecture, it is divided. The microprocessor unit or the processing unit is divided into two independent functional parts: bus interface unit or execution unit. Okay, these two units are there in this architecture, and then we divide the microprocessor, which in turn speeds up the processing. Names of two units you have to remember. This question is important. Bus interface unit and execution unit. Okay, this is the basic architecture. अगर आपको आर्किटेक्चर समझ में आया तो आगे की चीजें आपको समझ में आएगी. This is the entire architecture of 8086 microprocessor. It has two units, bus interface unit and execution unit. Bus interface unit is written as BIU in short form as well, whereas EU is the bus interface unit. नाम से आपको पता चलता है कि जो बस है they form an interface. Interface का मीनिंग होता है connection. Interface means forming a connection or providing a gateway for the communication to take place. Interface. In the bus interface unit, we have the segment registers. Okay, code segment. Yes, stands for code segment. DS stands for data segment. SS stands for stack segment. ES stands for extra segment. IP stands for instruction pointer. CS, DS, SS and ES, they are called collectively as segment registers. Okay. IP, it stands for instruction pointer. IP, it stands for instruction pointer. And in the bus interface unit, it is responsible for controlling the bus. Okay. And as in our day-to-day life, a bus is a mode of transportation, right? It carries people from one place to another place. So the same logic is applied over here. Your bus is, you can say, a mode of transporting instructions, a mode of transporting data from one place to other place inside the microprocessor. Okay, and it needs to be controlled. So the responsibility of controlling the entire bus traffic that is going on inside the microprocessor, it is the task of this bus control logic. Okay, it will control it. It is also connected to the external bus. Pay attention to the arrowheads. Okay, you have to pay attention to the arrowheads. Some lines can be directed in one way. Some can be bidirectional. Okay, you have to pay attention on the arrowhead. It is very, very important. Okay, clear all of you?
Okay. Yes,
Yes,
ma'am.
yes, ma'am.
There's a dotted line between, it is acting as a separation between the two units, execution unit and bus interface unit. Okay. Whatever data is stored in this segment registers, it is given to the bus control logic and then the instruction queue. Instruction queue, it is a 6-byte instruction queue. Okay. And it is responsible for storing the next instruction. Instruction is flowing from here to the instruction queue. Okay. And from the instruction queue, whatever instruction it is having, it is given to the arithmetic and logic unit. ALU stands for arithmetic and logic unit or arithmetic or logic unit. It is responsible for carrying out all arithmetic and logical operations. Okay?
Yes, ma'am.
And from this, the transition is going to the next part, that is execution unit. From the instruction queue, the instructions are also fetched to the internal bus. Okay, and it is also fetched to the ALU. Remember that instruction will be received from the segment registers through bus control logic to instruction queue, and finally they will be handed over to the execution unit. And in execution unit, we have the ALU, which is responsible for carrying out all the calculations. Okay, all the calculations, all the logical and arithmetic calculations, ALU is responsible for executing your instruction. That's why the instruction is taken from the instruction queue and it is given to the ALU. Okay, and along with ALU, after the operations take place, there are temporary registers that store the output. Okay, and then it is given to the internal bus, and then it can be given to registers. And listen, this is bidirectional flow. So the flow can take place from here also. You can directly give the instructions from here also. Okay. Apart from the segment registers, the 8086 microprocessor, it also has different kinds of registers. The first category in the execution unit is data registers. AX, BX, CX, DX. Okay, these are registers called as data registers. All the 4 registers can be divided into 2 parts, lower part and higher part. Okay, remember all the registers in 8086 microprocessor are of 16 bits. Okay, and the data registers, they can be divided into 2 parts, one of 8-bit and another of 8 bits. The lower part is called as AL. For AX, it will be called as AL. Higher part will be called as AH. For BX register, lower part will be called as BL and higher part will be called as BH. You can use these data registers for storing the data. The name itself tells you the purpose. You have to focus on the names, then you will definitely understand the meaning. Okay? डेटा रजिस्टर्स, उनका नाम ही है डेटा रजिस्टर्स. तो आप आंख बंद करके आपको ये समझ में आ जाना चाहिए कि डेटा रजिस्टर नाम ही है तो वो डेटा को स्टोर करने के लिए यूज किए जाएंगे. ओके, जैसे यहाँ पर AL और AL, BL, AH, BH इस तरह से डिवाइड किए गए हैं, उस तरह से CX और DX को भी आप डिवाइड कर सकते हो। समझ में आ रहा है?
Yes, ma'am.
After data registers in execution unit, we are having the pointer registers. उनका नाम ही है pointer registers, means to point something. Okay, means to point at some specific place. And there are two kinds of pointer registers in 8086 microprocessor. They are stack pointer, that is SP, okay, and BP, that is base pointer. Okay, stack pointer and base pointer. These are pointer registers. And after this, we have index registers, two index registers, source index and destination index registers. Source index register and destination index register. Okay, we will see each and every part of this execution unit and bus interface unit further. Okay, इनके साथ साथ execution unit में flags ये भी होते हैं. Flag, there are many flag registers. Okay, flag can be set and reset, set and reset depending upon the conditions. Depending upon the conditions arise when any kind of operation takes place. Okay, suppose carry flag है, अगर आप एडिशन कर रहे हो 2 नंबर का और कैरी जनरेट हुई है तो कैरी फ्लैग सेट हो जाएगा. समझ में आ रहा है?
Yes, ma'am.
Yes, ma'am.
Okay. Any query in this slide? We will see the description further. Shall I move further then?
Yes, ma'am.
Yes, ma'am.
Now we will see each and every unit. First, the execution unit. What is the task of execution unit? It will tell the bus interface unit where to fetch instructions or data from. It decodes the instructions and it executes instructions. Okay. This is the main task. These are the main tasks of execution unit. It will tell the bus interface unit from where you have to pick up the instructions and data. Then it will decode the instructions and then it will execute it. Okay. The execution unit, it contains control circuitry which directs internal operations. Okay. It also has a decoder. It also has a decoder, and the name itself says that to decode, okay, to translate instructions fetched from memory into a series of actions which the EU carries out. Okay, and it also has 16-bit arithmetic logic unit ALU, which can add, subtract. It can also perform logical operations and, or, XOR, increment, decrement, complement, and as well as shift binary numbers. Okay, so all these tasks can be performed by the ALU. So the main functions of EU are decoding of instructions and execution of instructions. Okay, clear?
Yes, ma'am.
Yes, ma'am.
Now these are the steps that it follows. The execution unit, it will extract instructions from top of queue बस इंटरफेस यूनिट. ओके, इंस्ट्रक्शन क्यू कहाँ पर है? यहाँ पर. कहाँ पर, कौन से कंपोनेंट में, कौन से पार्ट में है? बस इंटरफेस यूनिट में. और क्यू का टॉप साइड क्या है? ये यहाँ से क्यू में एंटर होता है और यहाँ से सामने जाता है. क्यों पता है ना आपको? आप लाइन में खड़े होते हो. आप सपोज आपको यहाँ पर इलेक्ट्रिसिटी बिल फिल करने जाना है, वहां पे बहुत बड़ी लाइन होती है अक्सर, राइट? तो एंटर कहाँ से होते हैं? क्यू में एंटर कहाँ से होते हैं? लास्ट से. और एग्जिट कहाँ से होते हैं? फर्स्ट से. समझ में आ रहा है?
Yes, ma'am.
ओके. सिमिलरली जो भी इंस्ट्रक्शन है, ओके, वो इसमें क्यू के अंदर एंटर होगी एंड फ्रॉम द टॉप साइड इट विल बी गिवन टू द एग्जीक्यूशन यूनिट फॉर फर्दर प्रोसेसिंग. तो यही इसका मीनिंग है यहाँ पर. PU extracts instructions from top of queue and the queue is present in BIU, that is bus interface unit. And the next task what it does, it will decode the instructions. Okay, जो इंस्ट्रक्शन है उसको डिकोड करना है एंड देन फिर उसमें क्या क्या चीजें रिक्वायर्ड है, कौन से ऑपरेंड रिक्वायर्ड है. Okay, that data is taken. It generates operands if necessary. All of you know that what do you mean by the word operand? पता है ना? पता है कि नहीं पता है? Operand, come on.
Ma'am, heavy operators.
Yes, operand are that we can say numbers or on which some kind of
Operators.
operation will be
Operated.
operated. Okay. So operator, you cannot say that operand are operators. Operators, they perform some kind of operation on these operands. For example, over here, if I say s equals to 10 plus 5, s equals to 10 plus 5. So how many operands are there and how many operators are there over here?
Operator is 1 and operands are 2. Plus is operator.
Read the statement again. S equals to 10 plus 5. How many operands are there? Come on, think.
2 operand.
Yes, very good. What's your name?
Akash.
Yes, Akash, very good. There are two operators over here and 3 operands. 2 operators and 3 operands are there. I heard that you said 2 operators. Okay. So, समझ में आया कैसे? Don't forget that is equal to also an assignment of. Remember?
Yes, ma'am. Yes, ma'am.
Okay. So in this statement, there are 2 operators and 3 operands. Okay. So obviously we will give the instructions to the processor, and from that instructions, the execution unit need to generate the operands if necessary. After this, it passes operands to BIU and requests it to perform write bus or input output. Okay. After this, the operands are passed to the BIU, and if we need to take data from user, okay, if you need to enter the values, okay, then the BIU will rewrite the data because we need the bus over there for reading and writing. And after this, the execution unit, it performs the operation specified by the instruction on operand. अगर addition बोला है तो addition होगा, subtraction बोला है तो subtraction होगा, and you will get the final answer. Clear?
Yes, ma'am.
Now next part, bus interface unit. Bus interface unit. The bus interface unit, it sends out addresses, fetches instruction from memory, reads data from ports and memory, and writes data to ports and memory. Okay? ऐसे समझ लीजिए, बस इंटरफेस यूनिट का काम है पूरा ट्रांसपोर्ट को कंट्रोल करना, ट्रांसपोर्टेशन। अगर यूनिट नहीं है, your microprocessor cannot work. Okay, got it? So the bus interface unit, it is responsible for sending out address, reading the instructions from memory, reading data from ports and memory, and also writing data to ports and memory. Input, output, सारी चीजों के लिए, सारे operations के लिए you need a bus interface. Okay. So in simple words, we can say that the BIU, it handles all transfers of data and addresses on the bus for the execution unit. Okay. Bus interface unit सब कुछ data collect करके execution unit execution work करता है, operations perform करता है, and output generate करता है. Okay, and output is given back for storing to the bus interface unit. Got it?
Yes, ma'am.
Any query in this architecture?
No, ma'am.
Ma'am?
No, ma'am.
Yes.
Ma'am?
Yes.
Ma'am, what is the difference between encoding and decoding?
Encode means putting the data in it. Okay? And decoding means bringing out the data from it. Okay? Encode means it's an input thing. And decode means you are extracting information from it. Got it?
Okay, ma'am.
For example, you have encryption, decryption. अगर आपने सुना होगा तो.
Yes, ma'am.
Yes, ma'am.
So like that. It's a reverse process. Decoding is the reverse process of encoding. For example, there are many phrases like this: compiler, decompiler, assembler, deassembler. As compiler, it will translate in machine language, and along with it, we have the decompiler that works at the background. Its task is to convert from machine language to higher language. Similarly, encoding and decoding. Encode means to do the coding, to do the coding, and decode means to extract from that particular coding. Any other query? No query then, I'll move forward. The iterating microprocessor, it is having a pipelined architecture. Pipeline. Okay. For example, at our home, we have the pipelines. And what are the pipelines used for? They are connected to the water tank. And from the water tank, the water flows throughout our home, through the taps. Right? समझ में आ रहा है? I'm trying to relate with general life example. Are you getting pipeline?
Yes,
क्या है?
ma'am.
Yes, ma'am.
The
Yes,
similar-
ma'am.
Okay, the similar thing, the similar function is carried out over here. Okay? And here, consider the bus interface unit as a water tank. Through the bus interface unit, different pipelines emerge. All the data, information, instruction, it goes through the instruction pipeline to the execution unit. Okay? And the bus interface unit is also connected to the system bus. Okay? So, the bus interface unit, it is responsible for the pipeline architecture of 8086 microprocessor, and it connects different bus or units to this architecture. Now we will see details about it. While the EU execution unit is decoding an instruction or executing an instruction which does not require use of the buses, okay, the BIU touches up to 6 instruction bytes for the following instructions. Okay, तब touch करता है BIU next instruction को जब execution unit it is decoding or executing an instruction. जब execution unit को bus का requirement नहीं है, that means the bus is empty. Okay, at that time, what the BIU does, it fetches up to 6 instruction bytes. Up to 6 instruction bytes. Okay, for the following instruction, for the next instruction to come. And after fetching these instruction bytes, what happens? The BIU, it stores these prefetched bytes in a first in, first out register set called a queue. Queue जो प्रिंसिपल पे वर्क करता है उसको कहते हैं हम फर्स्ट इन फर्स्ट आउट. जो पहले अंदर जाएगा वो पहले बाहर निकलेगा. That's the generalized meaning of first in first out principle. समझ में आ रहा है?
Yes, ma'am.
And this register set, it is called as a queue. It is called as a queue. क्या नाम है इसका? queue. हमको पता है queue क्या होती है, कि हम बहुत बार लाइन में खड़े रह चुके हैं. Just enter from here and you exit from here. Okay, and when the EU is ready for its next instruction from the queue in the BIU, this is a much faster than sending out an address to the system memory and waiting for memory to send back the next instruction byte or bytes. When the execution unit is ready, उसके पास जो already instructions थी उसको process करना हो गया. So after that, it is ready for the next instruction. Okay, and then वो कहाँ से fetch कर रहा है? वो fetch कर रहा है BIU से. BIU is the bus interface unit. And ये जो process है, it is very much faster. This process of fetching the instruction, the next instruction from the queue in BIU to EU. कहाँ से कहाँ ट्रांसफर करना है आपको? नेक्स्ट इंस्ट्रक्शन BIU में है, वहां से उठाकर आपको EU में उसको लेकर आना है. एंड ये ट्रांजिशन जो है, इट इज वेरी फास्ट एज कंपेयर्ड टू सेंडिंग आउट द एड्रेस टू द सिस्टम मेमोरी एंड वेटिंग फॉर द मेमोरी टू सेंड बैक द नेक्स्ट इंस्ट्रक्शन बाइट और बाइट्स. ये सेंटेंस समझ में आया? समझ में आया क्या?
Yes.
ये वाला सेंटेंस. There are some exceptions in case of JMP and call. हम देखेंगे. Jump, JMP stands for jump instruction. Jump क्या instruction क्या है, ये आपको already पहले ही पता है. C language में हम लोग go to use करते थे to jump from one place to another place. Unconditional jump. जिस तरह से go to C language में है, वैसे यहाँ पर JMP है to jump from one to another instruction. Okay, so and call आपको पता है, यूज किया है आपने function call. Consider the function call as the call instruction over here, CALL call. तो जो काम वहां पे function call होता था, function call का होता था, वही काम यहाँ पे call instruction का होगा. C language में हम function call यूज करते थे function को. Another name of function is subroutine. Subroutine को call करने के लिए into a main program. Similarly, in assembly language programming also, the call instruction will be used to call the subroutine into your program. So, except in these exception है ये, इन दोनों केस को छोड़ के, okay? इन दोनों केस को छोड़ के, except in the case of JMP and call instruction, where the queue must be dumped. मतलब जो queue है उसको हमको dump करना है, यानी जैसे उसको follow नहीं करना है, and then reloaded starting from a new address. This refetch and queue scheme greatly speeds up processing. समझ में आ रहा है? यहाँ पे क्या हो रहा है कि अगर आप जंप या कॉल इंस्ट्रक्शन यूज कर रहे हो तो ऑलरेडी पहले से जो इंस्ट्रक्शन आ चुकी है वहां पर तो कंट्रोल नहीं जाएगा. सपोज आपका प्रोग्राम यहाँ पर है, लेकिन और उसका आने वाली इंस्ट्रक्शन उसके बाद में ये है थर्ड इंस्ट्रक्शन 1 2 3, बट यहाँ पर आपने क्या लिखा है? जंप करना है आपको फिफ्थ लाइन पे, जंप करना है फिफ्थ लाइन पे. लेकिन इसमें इंस्ट्रक्शन क्यू में तो ये वाली इंस्ट्रक्शन स्टोर है, लेकिन क्योंकि जंप इंस्ट्रक्शन आप यूज कर रहे हो और जंप आपको करना है ये यहाँ पर, तो जो ऑलरेडी इंस्ट्रक्शन क्यू में जो भी डिटेल्स है उसको इरेज करके हमको जो फिफ्थ लाइन पे जो है उसकी इंस्ट्रक्शन का एड्रेस चाहिए. समझ में आ रहा है आपको? तो हमको रीलोड करना पड़ेगा इंस्ट्रक्शन क्यू को इस केस में. And this prefetch and queue scheme it greatly speeds up the processing. समझ में आ रहा है? नहीं समझ में आ रहा?
मैम एक बार रिपीट करो मैम।
इन जनरल प्रोसेसिंग अगर आपको इंस्ट्रक्शन ऑलरेडी रेडी मिल रही है प्रोसेसिंग करने के लिए एंड देन फिर आप उसको ALU को दे रहे हो विच इज इन एग्जीक्यूशन यूनिट, तो जनरल केस में दिस प्रीफेच एंड गिविंग रेडीमेड इंस्ट्रक्शन टू ALU फॉर प्रोसेसिंग इट स्पीड्स अप द प्रोसेसिंग जनरली। लेकिन इसका एक्सेप्शन क्या है? एक्सेप्शन है सिर्फ 2 ही इंस्ट्रक्शन, जंप एंड कॉल। जब आप जंप इंस्ट्रक्शन यूज करोगे, जनरली क्या होगा प्रोग्राम में, इंस्ट्रक्शन क्यू करंटली ये इंस्ट्रक्शन सेव कर रही है। अगर आपका प्रोसेसिंग ये चल रहा है तो नेक्स्ट इंस्ट्रक्शन वो ये सेव कर रही है ना? इंस्ट्रक्शन क्यू का वर्किंग समझ में आ रहा है क्या? प्रोग्राम की आने वाली नेक्स्ट इंस्ट्रक्शन को वो स्टोर करती है। समझ में आ रहा है? यस, इंस्ट्रक्शन क्यू का काम समझ में आ रहा है क्या? वो इस तरह से 6 बाइट इंस्ट्रक्शंस को स्टोर करके रख सकती है इंस्ट्रक्शन क्यू, एंड उसमें जो एकदम टॉप में है दैट इंस्ट्रक्शन विल बी गिवन टू द ALU फॉर प्रोसेसिंग। यस, इतना समझ में आया? ओके, सो अगर इस तरह आपको ऑलरेडी इंस्ट्रक्शंस पहले ही यहाँ पे मिल जा रही है, so this prefetch and queue scheme it increases the speed of processing. बट यहाँ पे एक्सेप्शन 2 है, JMP एंड कॉल इंस्ट्रक्शन। JMP एंड कॉल इंस्ट्रक्शन ये क्या करते हैं? करंट जो एग्जीक्यूशन का फ्लो है उसको बदल देते हैं। जंप मीन्स जंप क्या करेगा, यहाँ से डायरेक्टली क्या करेगा, सेकेंड इंस्ट्रक्शन पे न जाते हुए सपोज 4th इंस्ट्रक्शन पे आपने जंप कर दिया तो क्या होगा, इस चीज को टाइम लगेगा, इसको करने के लिए टाइम लगेगा क्योंकि फिर से क्या करना पड़ेगा, हमको प्रोग्राम में जाना पड़ेगा, 4th लाइन पे कौन सी इंस्ट्रक्शन है वो लेना पड़ेगा, वो लेने के बाद फिर यहाँ पर उसका एग्जीक्यूशन होगा। तो सिर्फ ये 2 केस में, कॉल में भी वैसा ही है, जंप में भी वैसा है। कॉल एंड जंप इंस्ट्रक्शन दे ब्रेक द रेगुलर फ्लो ऑफ योर डेटा और इंस्ट्रक्शन। समझ में आया अब?
Yes, ma'am.
Okay, and fetching the next instruction while the current instruction executes, this is called as pipelining. This is called as pipelining. Any query in this? Any query in this?
नो मैम।
पाइपलाइनिंग समझ में आ गया सबको? आप कहते हो ना, आई हैव दिस टास्क इन पाइपलाइन, आई हैव दिस वर्क इन पाइपलाइन, दैट मीन्स currently you are already doing work and you have another task to be completed soon after you finish the current task. Got it?
Yes, ma'am.
Okay, we will stop over here.